The title of this note is Rules for Differentiation. And in these rules, you're going to, in these notes, you're going to use the rules of differentiation to algebraically determine derivatives quickly. The idea here is to learn all of our shortcut rules so we can do derivatives as fast as possible. So a couple of basic rules to start with. So our constant rule. If you have a function that is a constant, for every input we have the same output. So this would be like y equals 5, y equals 6, y equals -3. The output is always a constant. The derivative is always going to be 0. The power rule is the rule that we discovered in class. So the power rule says that if you have a function that is x to some power, where n is a power, the derivative, you're going to bring the power in front, multiply it by x, and then you're going to drop your exponent down by 1. Whatever your exponent was, it's going to decrease by 1. Next rule we have is going to combine these two. It's called the constant multiple rule. And that rule says, what if you have c times some function, f of x? So this is saying, like, c is a number, so what if you have 3 times x squared? Okay? So the derivative of that, you just pull the c out in front. So what this is really saying is, okay, I want to do 3x squared. I think the rule is trying to overcomplicate something that's not complicated. What's the derivative of x squared? It's 2x. And then you still multiply it by 3. So it's 6x. The way we talked about this in class is we said, okay, you just multiply the exponent by the constant. Gets you to the same end. The sum and difference rule says that if you have two functions, f and g, and you're going to add or subtract them, that their derivatives are also added or subtracted. So again, we saw this in class where we said, okay, what if you have x squared plus 3x? Well, then you just take the derivative of all the pieces and add the derivatives together. So this is f plus g, and this is f prime plus g prime. You just add the derivatives together. All right, so here are two rules that we did not study in class, and we're going to study these further in class on Wednesday: the product rule and the quotient rule. These are very big, very important rules that you're going to want to spend a lot of time memorizing. So the product rule says, what if I have two functions that are being multiplied together? And the way that we will write this is we're going to say, what if f of x is defined as two functions, u times v? And for shorthand, I'm going to call it u times v. I'm going to drop the of x notation. How do you find the derivative of two functions that are being multiplied by each other, u times v? So we're going to use a rule called the product rule. And the product rule says that the derivative will be u times v prime plus v times u prime. And you will actually hear me say uvu. This is the way I memorize this formula. I just read it like it's a word, uvu. And then similarly, we're going to have the quotient rule. We're going to define a function as two functions being divided. So all of our rational functions can follow the quotient rule. And again, I'm going to call this u over x, u over v to simplify. So the quotient rule will be almost the opposite of the product rule. So instead of uv prime, it's going to start v u prime. Instead of a plus, it's going to be a minus, and then u v prime. And then here's the only piece that's really different, divided by v squared. So you'll hear me call this one vuv. So we have uvu, our product rule, and vuv, our quotient rule. And we'll spend a lot of time in class going over those rules and how to use them. The last thing I want to talk about is second and higher order derivatives. So we've been talking about taking a derivative. It's called a first derivative. Well, you can take a derivative of a derivative. That would be called the second derivative. You can take the derivative of a derivative of a derivative. It's the third derivative, and you can go on like this forever and ever and ever. So I'm going to pull an example out of the book. I'm on page 123, example number 8. And the function there is x cubed minus 5x squared plus 2. So let's find the first derivative. So the first derivative, take the derivative of x cubed, it will be 3x squared. Take the derivative of minus 5x squared, it'll be minus 10x, because I'm multiplying the 5 and the 2. And then lastly, derivative of 2 is 0. I don't need to write plus 0. So that's the first derivative. I can now take the derivative of the derivative, the second derivative. It gets 2 slash marks. All right, multiply the exponent and the coefficient, and subtract 1 here. 2 minus 1 is 1. Multiply the exponent and the coefficient. Drop this down by 1. X to the 0 power is just 1. It's a single number. Okay, I could keep going. I could find the third derivative. Find the derivative of the derivative, and that would be 6. Remember, derivative is just slope. This is a line with slope of 6. And I could keep going. Once we get past the third derivative, once you get to the fourth derivative, we don't use slash marks anymore. We would just write the number 4. So the fourth derivative, this is a constant. So going back to my constant rule, the derivative of any constant function is 0. Because if I graph y equals 6, I have a line with slope 0. You do stop once it's 0, because once you get to 0, the derivative of 0 is always 0. So it's not interesting to go past 0. But you can take the derivative as many times as you want. That is the end of these notes. So go ahead and draw your line and come into class ready to talk about product and quotient rule.